So when we're solving our x quadratic equations by graphing, here are the steps we're going to do. We're going to write the equation in standard form, and we're going to set it equal to 0. So in other words, they're going to probably give the equation without a y in it. And we're going to rearrange the equation so that we have it in standard form, ax squared plus bx plus c, and we have a 0 on the other side. Or if there is a y in it, we could replace the y with 0. And then we're going to graph the related function. So now we are going to graph it as if that 0 is a y. And then we're going to determine the zeros of the graph. These are going to be the solutions. Okay, so if we're going to solve this by graphing, first step was you have to make sure it is set equal to 0. So what's our first move going to be in this one? We have x squared plus 2x equals 3. Is it in standard form set equal to 0?
Yeah. No.
No. So what would be our first move? Add 3 to both sides?
Yeah.
Would that move that 3?
-3. Add -3.
What do we need to subtract 3 over here to get 0?
1.
So we're going to subtract 3 from both sides. Okay, so our equation now is going to read x squared plus 2x take away 3 is equal to 0. Now it said, in the next step, it said graph the related quadratic equation. So we are actually going to replace our 0 with a y, and we're going to write our equation. So all they did, and it wouldn't matter, we could just have the y on the other side. We could have a 2x or x squared plus 2x minus 3 equals y. Doesn't matter. Because what we're going to do is identify our a, b, and our c to help us graph this. What's our a value? 1. What's our b value? 2. And our c value? -3. Okay. So the first thing we're going to find is our vertex. Anybody remember our little formula that we used that helps us find the x value of the vertex?
X equals -2 over 2.
Yeah, so we use x equals negative, and then we have b over 2a. So we will substitute into that little formula. We're going to put a 2 in for our b, and a 1 in for our a. And we have a negative 2 over 2, which is what? What's that equal to? Negative 1. So we're finding the vertex. We now have to find the y value of our vertex. So remember, we have to take our equation. I'm just going to write it down. Then we're going to substitute into it what we got for our x value of the vertex. And we have to make sure we're really careful about, that's a -1, so it's got to be in parentheses. So, and we have another place to substitute our -1 in for. So -1 squared is, what is -1 squared, class? You don't need a calculator for this. +1. What's 2 times -1? -2. And we can change that to add the opposite. We have plus a -3. So we can add in any order we want. Let's add those two negatives together first. What's -2 plus -3? -5. Go back and add 1 to it. -4. So our vertex is ordered pair -1, -4. Let's just go put that on our graph right away. -1, -4. This is where some of you had troubles. When you put the vertex on, does the vertex have a reflection point? No, we don't reflect the vertex, do we? So in reality, what we could do, maybe to keep us from doing that, is draw that axis of symmetry that goes through it, so we remember we're going to reflect over that line. So draw the axis of symmetry going through it, showing that that point is on that axis. It's not going to have a reflection point. Okay, so now that we have our vertex and we have it graphed, what's the next point we typically locate?
Y-intercept.
The y-intercept. So now we'll go and find what's the y-intercept.
0, 3.
And that is going to be, because c is equal to -3, we're going to say the y-intercept is 0, -3. So now we'll put that point on our graph. Does that one have a reflection point?
Yes.
Yes, it does. So now we go and reflect that one. And now we have 3 points. How many do we need?
5.
Okay, here's what we really need to do. We gotta find them until, we might even have to do more than 5. What we have to do is we have to find them until, because we're looking for the zeros, remember? We're solving by graphing, and it said you need to find the zeros of the function. So we have to graph till we get those zeros. So what should we try first here? What x value could we try?
1.
1. We could try when x is equal to 1. So now we're going to find another point. And we're going to do it when x is equal to 1. We're going to try that one. So we're putting into our equation y equals x squared plus 2x minus 3. And we can't say, well, we already did it for -1, it should be the same. No, not necessarily. So 1 is positive, so it doesn't have to be in parentheses. And I'm going to change that to plus and -3 right away. Okay, y equals, this is 1, this is 2, this is -3.
0.
So that's 0. So what ordered pair do we have?
0.
1. We get when x is equal to 1, we got y is equal to 0. So now we'll go to our graph, and we will plot that point, 1, 0. And does that have a reflection point?
Yes.
Yes, it does. We go over 2 to the other side of the axis of symmetry and reflect. Now remember, we're looking for the zeros of the function. Have we found them yet?
Yes.
We have, haven't we? Remember, zeros of the function are where the parabola is going to cross the x-axis. We just found those, didn't we? So we get to say we have found enough points, so now we're going to draw our parabola. You get to stop. Sometimes you might not get to, you might have to find that another, you might have your 5s and still you can't tell, you don't have a point on the x-axis, so you're going to keep going. We ended up with a point on the x-axis, so we get to say that we are done with that. Okay. Now we're going to say, then we now know the solutions for this quadratic function. So underneath your graph, I want you to write, therefore, okay, well, no, let's do this first. Let's say, the zeros are what?
-3 and 1.
Okay, zeros are -3, comma, and 1. Don't put those in parentheses because that makes it look like an ordered pair. Those are the 2 x values where the graph is, the parabola is crossing the x-axis. So our zeros are -3 and 1, so we're going to say, therefore, the solutions for y equals x squared plus 2x minus 3 are what? What do you think they are? Up here. Back up here.
-3 and 1.
It says, determine the zeros of the graph. These are the solutions. So our solutions are x equals -3 and x equals 1. So we found our solutions. Here's what solutions really mean for a quadratic function. We're supposed to do check problems, by the way, but I think we're going to eliminate them. Okay. But I need you to tune in here, or I am going to make you do check problems. When we are solving a quadratic function, what we're really looking for is what numbers for x, when they are substituted back into that equation, will get you y equals 0. When you substitute back in, they will make the equation true. So you know what? We're going to go back up here. Let's just do it mental math. Okay? Here's our original equation right here. Let's make sure our solutions actually do get what they're supposed to. So what's one of our solutions?
-3.
-3. What's -3 squared? 9. So what's 2 times -3? -6. What's 9 plus -6? 3. And what's it supposed to be? 3. So that one checks out, doesn't it? So in other words, it has to make the equation true. Or another way to think of it is it has to make the y value equal 0. But there is no y in the start of this one. Okay, what's our other solution? +1. Okay, so what's 1 squared? 1. What's 2 times 1? 2. What's 1 plus 2? 3. So we get 3 like we're supposed to. It checks out, doesn't it? So I'm not going to make you do those check problems, but I want you to understand that we just found the 2 solutions this equation has. Not every quadratic function has 2 solutions. So you can't have any more than 2 solutions, okay? So you'll never get more than 2. But we will find out along the way that sometimes we're not even going to get 2, we might get 1, and sometimes we might not get any at all, okay? So we have to be able to use the skills we just used back in the previous lessons in this chapter. Now when we're done graphing, we're not done graphing until we can see where it is going to cross the x-axis, because we need those x values to tell us what the solution is for this quadratic function. So any questions on any part of this where you're unclear? Okay, then let's go to the back side. Solve x squared equals 9 by graphing. I am going to teach you how to do these algebraically, but we need to be able to do them by graphing also, just to see what happens. So what's our first step? Get it? Set equal to 0. So yes, we will subtract 9. So our equation is going to read x squared minus 9 equals 0. And remember, what are we going to replace that 0 with in our next step? With a y. So we're going to say y equals x squared minus 9 is our quadratic function that we're trying to solve. What's our a value? 1. Haley, you keep working with us. Our b value is? 0. And our c value is? -9. Okay. What's our vertex? 0, -9. Do you remember what we said when b is equal to 0? The y-intercept is the vertex. Remember that? Whenever b is equal to 0, it turns out that if you went through the work of putting it into the formula, did your x equals -b over 2a, you would find out that x equals 0. And then when you put 0 back into the equation, you'd get -9. And you'd end up with a y-intercept. So this is not only the vertex, but it is also our y-intercept, isn't it? So we're going to have to work a little bit harder at finding some extra points this time. So 0, -9, let's go put our point. Should this one open up or down? Up. Okay, so right here below, we're going to write that this is our vertex so that we remember we can't do what with it? We can't reflect it. We're tempted to, but we can't. Because, and the reason you might be tempted to this time is because it's also the y-intercept, and we typically reflect the y-intercept. Okay, so let's pick some x values that we could use to help us get some more points. So we need some more points. Find other points. This is also our y-intercept, so we can't do that one. So what x value do you want to use?
1.
X equals 1, okay. So, we'll put it into our x squared minus 9, y equals x squared minus 9. So we get y equals 1 squared, take away 9. What do we get? Negative 8. So what order do we have? 1, negative 8. Okay. We'll put that one on. 1, negative 8. How close that guy is. Okay. Are we reflecting that one?
Yes.
That one we are reflecting. Okay. So now what should we do? When x equals what? What do you want to do next? 2. Okay. And do when x equals 2 next. What'd you get for y?
5.
Negative 5.
How about negative 5? So now we got ordered pair 2, negative 5.
We still don't have our zeros.
We still don't have our zeros, do we? So now we're going to reflect that point. And so now we're going to do x equals 3. Okay. Well, hopefully we're going to eventually get it. So now we substitute into x squared minus 9. 9 minus 9. Y equals 0. Ordered pair 3, 0. Go to our graph. Reflect. And we stop.
Yes.
Yeah.
What determines like what points we pick? Like, could we have done like negative 3?
We could have done negative 3. Remember, we want to do points that are like, you know, like not very far away from the vertex, and just substitute them in and find other points. But today we don't get to quit until we do find the ones that are on the x-axis. Okay. So we now can draw our parabola. Let's get that drawn. See that yes, we do have our parabola that's opening up. And what are the zeros?
Negative 3 and 3.
Okay, the zeros are negative 3, positive 3. So we're not done. We say the solutions are, so solutions, what are they? X equals
Negative 3.
negative 3, and x equals 3. You know, when we solve linear equations, we end up with x equals a number. Same thing with quadratic. X equals a number. What are those two numbers that will make that equation true? Okay. So, this would be our final answer on this one. And I'm not going to make you do the check problems. Okay, any questions about that one? So remember, when b is equal to 0, your y-intercept is actually your vertex. We have that in our previous notes. Hopefully you haven't gotten rid of your previous notes. Okay, solve x squared minus 2x plus 1 equals 0. Do we have to get it set equal to 0? Do we have to do that first step?
No.
No. It's already done. So we can just say, I have an a there, we can just put that it is already set equal to 0. Step B. What do we do in step B? That's where we put the, what replaces what?
Y equals to 0.
Yeah, y replaces 0. So y equals x squared minus 2x plus 1. In other words, we're going to get ready to wrap it. So we need our A, B, and C. A equals 1, B equals -2, C equals 1. This time, is our y-intercept our vertex? How do we know? B has to be equal to 0, and it's not. So we're going to do our finding. Our first thing we're going to find is we're going to find our vertex. Okay, so we're going to find the vertex first. We're going to do x equals our negative b over 2a. So we're going to put, there's our negative sign. Our b is also negative, and 2 times 1 downstairs. So what's in, let's give this negative sign to the numerator. Remember, we get to give it to whichever one we want. So what's a negative -2? A positive 2. So we actually have positive 2 over positive 2. What's that equal? Positive 1. So we now know the x value of our vertex, don't we? So let's go over here now and let's write our equation down and substitute into it to find our y value. You already got it? You already got the y value of the vertex?
Yeah.
Okay, what is it?
No, I meant like the equation part.
Oh. One plus 1 is? Plus a negative 2 is? 0. Y equals 0. So what order of pair is this? What's our vertex? 1, 0 is our vertex. This is our vertex, remember, that's what we were finding. So now we're going to go to the graph and put our vertex at 1, 0. Okay, does that have a reflection point? No. Okay, so what would be our next point we're going to find?
Or the y-intercept.
The y-intercept. Okay, so next we're going to look for the y-intercept. What's our y-intercept?
0.
0, 1. Because c is equal to 1. So our y-intercept is 0, 1.
So it's not going to have any zeros.
It's going to be, there's going to be reflected right here. And it's going to open up, isn't it? Is that what we expect it should do? Should it open up? Yeah. Okay. Do you remember when back when we were starting to study zeros? We said how many zeros can there be?
3.
No, there's 3 different possibilities. What are they? You could have 2 zeros, it's crossing the x-axis into 2 different spots.
Or
1, 0, the vertex is sitting on the x-axis, then you only have 1, 0, or you can have no zeros. So when there's 2 zeros, there are 2 solutions. When there's 1, 0, like this one has, there's only 1 solution. When there's no zeros, it's not going to cross the x-axis, then we would say there's no solution. I'm going to let you stop here, and I'm going to let you say, you know what? We already found our zeros, so we can just do this. We're not going to find our 4th and 5th point, so sometimes you're going to have to find the 6th and 7th. Other times you might not have to find that 4th and 5th. Okay? You can, yeah, you can. That's you'll get a better practice on. So we have 1, 0, and what is it?
1.
0.
It's just 1, right? The 0 is 1. In other words, remember the 0 is the x value of that place where it crosses the, so it's the x-intercept. So now we're going to say our solution for this equation is solution x equals 1. It's the only solution